Right then. So from the last stream, not the last stream, the last sprite stream, we did this, where we had Hunchback moving backwards and forwards, and we had, if I can remember, there we go, jump. That is such a dainty jump. But the problem is, one of the things that no, you haven't, mate. So one of the things that I avoided was this. If I scroll Hunchback past Esmeralda and carry on going, boom, gone. And that is because he's there, look, he's hiding. And that is because the screen is bigger is bigger than 255 pixels, which is the equivalent of a byte, or 256 if you include 0. So how do we get a sprite to go into this area here? And and stop it. And there is another bit that you have to set that allows Hunchback to go across here, and that other byte and that byte is D010, and it's called MSGIGX. And basically it's a byte has 8 bits. That gives us our 256. But what this byte does, it gives an extra bit to the X value for all the sprites. So instead of being 8 bits, it's 9 bits, which means then you've got a range of 0 to 511 or 512 to be to allow you to move across into the other area of the screen. So the sprite actually can be addressed up to 511 pixels. I mean, the screen is only 320, I think, but the way that it's a pain up the backside to work it out, especially when you're trying to cross up and down, where you're doing that transition bit, because you have to try and figure out where you are. And so the way to do this is like when we're enabling the sprite, we set the bit for that sprite. So we have got, for Hunchback, we have 2 sprites. So that means we're going to have to set 2 bits in this to carry on, or we'll end up with Hunchback either being naked or is just his clothes carries on. But we can show that anyway. So what we need to do is we need to test for Hunchback crossing that boundary into the area, and we'll do that first because that's the easy one. The other one's a bit more difficult. So let's go back to the code. So this is the code that's currently on the thing. I have put the live share in Discord if you want to follow along. Who's pinging me? Oh. So what we need to do is in the update quasi routine, this is where we're doing the adding of the X value here. Yeah. So this is what we're doing. We're increasing sprite 0, X, and sprite 2. No, sprite 0, 1, 2. Yeah, sprite 2. And all we're doing is we're increasing it, and we're not taking consideration of where it crosses the page boundary. So what we need to do is we need to look at how we are doing this, and then apply the page boundary to that byte. So the dead easy one is if we increase, if you do an ink, does it set the carry? I don't think it does it? Don't think it does. Right, so we'll change this. Yes. So we're going to change the add routine. So we're going to load SPX CLC add #1, store it back in there. Yeah, but we can have a 0 legit. That's the only thing I'm worried about. Because you cannot. Yeah, I know, but we can still have 0 if we're going backwards. If we go that way. But yeah. So what we need to do is this. So we've increased it, it's got across the page boundary, it's gone back to 0, so we can test whether it's not equal to 0, right? And if it's not equal to 0, we'll come here, not crossed page. But if it's crossed the page boundary, this is where we need to now set the bits of that byte. And because we're using 1 and 2, so we need to load what's it called? Or it with. So we're setting that one and that one, 0 and 1. Let's just make sure I've got that in my constants. Yep, there it is. So that is now, I have no idea how to turn that off, guys, so I've tried. So that now should, if we run this, should allow, whoa, should allow Quasi to cross over. Let's have a look. So it's around here. There you go. Now the problem is, going back, we have a problem because we haven't done anything on the other direction. So we've sorted out, now he's stuck in this. He's stuck in this high bit area and can't get out. So what we need to do now is we need to sort out turning off those high bits. So in here we're going left, update Quasi. So he's doing that, jump, frame counter. Here we go. So we need to do exactly the same as what we did before. So we'll copy the code, because might as well. It's almost exactly the same. And we'll put it here. But this time now we've got to turn them off. So the way to do that is is we have to turn them off. So we do an and we go turn them both off, because remember Quasi is made up of two sprites, the high def sprite and his clothes. So we should be able to come back now. So he goes up, past Esmeralda, off the screen, comes back. We should now, there you go. Jump, jump, and it's simple as that. But like I say, if you get it wrong, so let's say we only do one sprite because we forgot we only made Quasi as a sprite. This happens. So as soon as he crosses, he gets naked and his clothes end up on the other side. Then we come back, his clothes and him should reunite. There you go. So you've got to remember this all the time. So you've got to remember that if your character is using two sprites, you've always got to make sure you set both of them identically the same. Now, this is the simple method. Yeah, we've only really got one sprite to worry about. Well, one set of sprites to worry about, which is Quasi, because Esmeralda stays still. Yeah. So it's easy to sort the high bit and the low bit. It's easy. But the problem is when you are, and also we're incrementing in ones. Let's say if we started incrementing in twos or threes, let's say if we got Quasi to jump 3 spaces, we would miss that page crossover and stuff. So we have to start then thinking of different ways of being able to set the most significant bit. Now, I personally don't interact with the sprites directly, especially on the setting of the X, setting of the Y, even sometimes with the colours and stuff like that. If you look in my Neptune lander program, I do not set the X and Y. I do not set it. I actually set something else, and then I've got there's a routine that takes all those values and then updates the sprites, and that is a more, how can I put it, reliable way of doing it, because what you can do is you can use 2 bytes for the X, yeah, the low byte and the high byte, but the high byte will only have 0 or 1 in it, yeah, and so then you just treat it as simple math. You use the add and subtract to it, and it works beautifully. Then what you need to do is then transfer that information into the sprite and do all the mechanics that we've just done here. So I'm going to do that here just to give you an idea of what I mean, yeah? Because we're going to change the way this works. We're going to change it into where we update some memory space and then we have a routine that updates the sprite. And it does all that working out for you, yeah? So let me create a copy of this. And we're going to call it V2. Get rid of V1 just in case we get messed up. So I'm going to create a new area, yeah? So sprites X for a better word, and then we're going to have 2 bytes. So this is effectively the low byte and the high byte. So that's where we're going to store the X information. And the reason I'm going to use this system is I'm going to change the way this works, yeah? So we need to store, every time we interact with the sprite X, we're going to store it in here. So for example here, so we're going to store it in that. We're going to get rid of that, because the beauty of this is you can use 1 byte for both sprites. So this is Hunchback. In fact, we'll do Esmeralda as well. So sprite X and sprite can't spell name. So we'll do both of them. So in fact, we'll change that to quasi. I'll do. So we'll do the quasi first. So here we are going to put it there. We're not going to set sprite 2. We're going to leave Y because Y isn't an issue, but you can apply because we're going but we can apply the Y as well to this mechanic, but we're not going to do it. We're just concentrating on the X, and the most significant bit. And so here that's quasi, so Esmeralda, quasi, this is going to be Esmeralda. Right. And basically what we need to do now is we need to work out, do all the updates and use the new locations. So we'll do quasi first. And what we're going to do here is we're going to convert, because I want to demonstrate by, no problem. What I want to demonstrate is the fact that when you start increasing the X's, so if you want to introduce speed to Quasi's character, this is the way to do it. So what we need to do is we need to go clear CLC, load Quasi. So this is the low byte. Add 1, store Quasi. and then load quasi +1, add 0, store it. So this is effectively doing the same thing as we did before, but we've converted it from an inc to an add, and you'll see why in a bit. Right, and then we don't need this, and we just need that. So we'll do the same with this. We'll do the same on this side as well. So we might as well copy this and do it here. But this time it's set carry, load quasi, subtract, and subtract. And don't need that. So this has we're now updating those memory values. So we're not talking directly to the sprite. We are updating memory values for the X. We're still talking directly to the sprite for the Y, but we're not for the X. And the reason why is because we want a routine to handle all that most significant bit malarkey and stuff like that. So this is what we need to do. Now we've updated the memory locations, we now need to put the memory locations onto the sprite. And so we need a sprite update function, and so this is what we're going to write in a minute. So we need a sprite update function. So update sprites. So how we're going to do this? Think. Yep. So I need a sprite mask. And these are going to be the 1, 2, 3, 4. So that's the first one. 2, 3, 4, 5, 6, 7, 8. So we're creating our mask that's basically going to turn on the high bit and turn off the high bit. Yes, mate, yes. So this is sprite 0. And this one will be sprite 7. 7. Oh, yeah, okay. I don't need that as well, do I? Right, so that's our sprite mask, and we're going to use this sprite mask to set our sprites. So, to do the sprite, we are going to send in some parameters. So, what we're going to do, how we're going to do it. So Y can be the sprite index. So Y is the sprite index. So basically when we run this routine, we're going to set Y to be the sprite number. So, and I want to set, I want to load the memory in. I want to load the memory in. We can do that in. Yeah, I know. I'm more about the memory location first. How are we going to do this? Okay, so we can put in A and X because we don't need A and X, right? So accumulator is going to be the low addressing point. X is going to be the high addressing point. Right, let's pick out a 0 page. No, let's not pick out a 0 page. Let's do it the old-fashioned way. So I want to we'll do 0 page. Right, let's pick one. That one, that'll do. So first thing we do is we're going to store A in there, store X in there. That's sorted that out. Right, and so that's now pointing to our low byte memory location. And transfer Y into A, we'll push that to the stack because we need to use that later. Do I need to use this? Yes, I do, because I'm sending in the memory location. Or do I have to? No, I'm overthinking this, John. You're overthinking this. X is high. Right. I know I'm overthinking it. Right. So accumulator is the low byte, so we can store that straight away into sprite 0x. Come on, Y. Oh, that's annoying. Annoying. Yeah. Right. Let's swap this about. So we'll make the accumulator the high byte. X is the low byte. It's alright. I can think on my feet. Right. Accumulator's the high byte, so we're going to push that to the stack because we don't need it yet. So we've now got the accumulator available. So we need to transfer Y into the accumulator. We'll push that to the stack as well. Now we need to times 2, because remember the sprite addressings are in 2 bytes, yeah, in pairs. So we need to times it by 2 if we're going to be addressing the sprite directly. Transfer back into Y. So that's now our index for the X of the sprite. So then we can what can we do now? So X is the accumulator is the high byte, X is the low byte, and I don't think we can store X. Right, so transfer X into A, store A in sprite 0 X comma Y. So that's the low byte stored. We will pull, yeah, we pull the A back, transfer it back into Y, and pull it again, and this is the high byte. So now what we need to do is we just need to do a quick test. So compare with 0, branch if equal to do nothing, plus not in this routine, no. In fact, we'll call that that. So we're doing nothing, and so now if it's 1, we need to set the most significant bit. So what we need to do is we need to go load ms. Just make sure I get it right. That, or it with sprite mask comma Y, because we've now brought that back, store it in ms, and here's do nothing. So that sets it to be right, so that's just to work out the Y. You're storing the low in the X, pull in the Y back, the original Y, because we don't need to times it by 2 anymore, transfer it to Y, pull the high byte, compare it with 0, branch if equal do nothing. So, well, there's a problem with this. When the high byte's set, how do we turn it off? Well, that's easily. Yes, stop trying to beat me. So what we're going to do is we are going to load $FF EOR with the mask comma Y, because we've got Y back, and it with MSGX, and then store it with MSGX. Then we bring the high byte back, compare it with 0, and if it's set, we reset it. If it's not, it's cleared. Not that far yet. Then we're going to do an RTS. Right. I should do it. So now we need to, so that's going to update the X. So we set it, where's the game loop gone? Where's the looper? Here we go, looper end. Does everything go back to looper end? I did. Here, I loaded FFF and then EO'd it. So, if everything's going back to looper end, let's go in there. We can put it here. So let me get another one up. Right, so that's the routine. So right. So this is where we do the jiggery pokery now. So we load Y hash 0, so sprite 0. Load the accumulator with the high byte. Where is it? Quasi +1. Missed it, gone too far. Load X with quasi, update the X sprite. So that's going to update the sprite 0. Then we need to do the same for sprite 1. Yep, should do it. And then we do repeat and rinse and repeat with Esmeralda. Now I know some of you are going to be going, you can make this more efficient. Yes, we can, and if I've got time I'll go into it and we'll make it even more efficient. But at the moment I'm just trying to get the concept across. So now we're controlling, so that's going to be 2 and 3. So now we're controlling, it's just the X bit. It's just the X bit we're talking about, not the Y, and we'll, if we've got time, which we seem to be racing through this, we might do, is we'll do the Y's as well, and then we can have the whole update sprite routine based on an array of bytes, and use that, and then we have the update routine that just looks after itself. So here, this update X is doing all this. So it's basically doing what I did before with a little bit more, because we're passing in three values. Y is the sprite number, A is the high byte, X is the low byte, and then we update the sprite location, and that's the actual sprite location from the memory. Then we're doing it for sprite 1 for quasi, then we're doing Esmeralda both 2 and 3. So hopefully, fingers crossed, this should work. And it failed because what have I forgotten again? Oh. Come on, get on the screen. Well, he's there. Does he move? Go on, go on. There we go, there we go. So now, when we, as a programmer, now this routine's been written, we as a programmer don't have to worry about this high byte anymore. As long as we send in the X low coordinate and the X high coordinate and tell it what sprite it is, it does it for us. And so you don't interact with the sprite direct. And the reason why I say that is, let's say if we want to make Quasi run quicker, yeah? So, update Quasi, where is he? Here we go. Let's say we want him to go 2 pixels backwards and 2 pixels forward. Let's say we've got, I'm hard coding it here, but let's say if we have a byte that the longer he runs, the slower he gets. Let's say if we get him to run and he jumps 5 pixels at a time, but the longer he runs, we could reduce the pixels because he'd get tired, so he would run slower. This takes care of it. We don't have to worry about setting the high byte and working out if it's crossed the page boundary, because our routine does it. Right? So this now should be where he's moving twice as fast, but he should still cross that page boundary and still carry on. So here we go. There we go. Go on, go on, go on. Lovely. Look at that. We no longer have to worry about the MSG. We've got that routine to do it for us. It is working out whether we need to set the high bit or not. And this allows us to be you can do that, Gray, but then you have to do it for every sprite. You have to write that routine for every sprite. You have to manually write the routine. This is why I did that update X, because all we're doing then is just send that routine information, let it do it, and so we don't have to keep writing it left, right, and centre. Because I've seen people where they're directly writing to the sprites and they get themselves in a right mess because they're having to check the most significant bit every time they do the update, and I can't see why. When you can write a routine, and as long as you understand what you're going to pass to it, then away we're going. Is this jump sorted too? No, we've got to go in there and sort that out. So the jump. Oh yeah, the jump's sorted. Because the jump is only concerned with vertical. It's not concerned with horizontal. Right, here we go. Whee! So we'll cross the boundary. Anyway, he's jumped across the boundary, and he's jumped across the boundary again. Yes. Yeah, you can do that, yeah. But then, why did I not do that? It was in one of my early Neptune Lander video. Oh, it's when I started using fractions. It throws it all out the window. Absolutely, completely tears it apart when you start using fractions. And that's why I started using this method. Just send it the low bit, and the high bit. Done. The only difference between what I've done here and what I did in Neptune Lander is I've made it a proper go sub, jump subroutine. As in Neptune Lander, I did it as macros, so I called the macro. So it repeated the same code everywhere and everywhere, but this doesn't. You've made a go sub, so you've only got the one code, and all you do is make sure you populate it and call it. So we could do the same thing with the Y for Esmeralda and Hunchback. But then you're starting to talk about arrays. You know, you're starting to talk about how you're going to manage your sprites, and this is where you start thinking about, do I want to manage the whole sprite using an update routine where I don't interact with the sprite whatsoever, and I just set the properties in the array. So I have an array of sprite color, I have an array of X, I have an array of Y, I have an array of have I collided, I have an array of for animation and stuff like that, which is similar to what Derek did, but he used macros, and I've been writing some sprite management stuff using JSRs to do all that, because I think macros are great, but you're just using the same code again and again and again, and using shed loads of memory doing it. At least this way you have one update routine that is called after you've done everything, that then updates all the sprites, and then you do the next cycle, which you then update them all. And also the beauty of it is, if you start using an array of data to control the X and Y, then it means you can then, your update sprite routine could then be a multiplexer, because then the number of sprites doesn't have to be limited to just 8. You could have 20 sprite array, and then your update sprites would be the multiplexer taking information for those sprites and setting them on the screen as it goes down the raster. Now, I'm not going to go into that today. The whole point of today was trying to explain how to get the sprite on the other side, and how to do it in a quick and easy way that allows people then to use the full screen instead of being scared to move over in there and then suddenly start saying, well, that's where all my scores are going to be, because they're scared of doing the most significant bit. And now you don't need to. This little routine here will solve all the problems. I know it was your idea, but this routine will allow you now to use the whole screen. All you have to do is pass the sprite number, the X low of it and the X high of it, and it works it out. So we could do the same with the Y. You could have an update sprites Y, and then you could have a parent routine that just literally loops through your 8 sprites if you've got all 8 sprites used, and updates all of them using these routines. Now, I understand what you're saying, but once you get used to this, if you look at this function in isolation, just look at it on its own, like now it's on the screen, you should be able to see with comments, because you know I've got to put comments in here, so you know, yeah. Steak. Is that steak? Times by 2. Put back into Y for X indexing. Get low byte. Store in sprite low x low. So here we're getting back sprite number, transfer to y, load, get no, we'll leave that one, don't need that. Make inverse mask. So that would be changing that to that. Clearing out most significant bit, store back, Alright then, Mark, work it out. So to do the inverse mask, yeah, it's going to take 8 bytes because you need to do the inverse of everything, right? Then this would become a load and store, yeah. So effectively saving 2 bytes in the code, but then we're using 8 bytes for the mask, so we're net spending 6 more bytes. With this system we're saving 6 bytes because we don't need them have the mask because we load FF. This would be a load, but we're now doing EOR and then we're doing the AND. So it's just memory saving. If we were using inverse masks everywhere else, then yes, I would say yeah, because that could be applied, the inverse masking could be applied everywhere else. But in this particular scenario here, we don't need to. Yeah? Yes, it's a trade-off. You have to, only you would know if you need an inverse mask in more than one place. If you need an inverse mask in say 2 places, I still go with this route. I'd still go with this because you're still saving memory. The trade-off would be as soon as you needed the 4th inverse, if you needed to do it 4 times, because then having your inverse mask in bytes would be then more beneficial in memory because you would be using less memory from that point onwards. But in this context, yes, exactly. If you was doing them all at the same time, which we're not in this particular case, we're setting 1 at a time. So let me finish commenting this. So we're bringing back the high byte. Is it 0? If so, do nothing. High byte is 1 and can only be 1. It won't be 2 or 3. Set most sig bit of sprite X. Store back. Hopefully now those comments help in the understanding of this routine. Yes, exactly. Yeah. If you was for example, multiplexing, if you were setting all eight at the same time in a multiplexer, then you don't need to do this, because you would just set you would work out the high byte bit structure based on, because you're setting them all at the same time. Is that true? Really? Okay, let's give it a go. Here we go. Well, I never. Well, I never. Every day's a school day. Well, I never. Thank you. I'm going to have to get that 6502 book out again. So the PLA does it. No, got my new book. Can you see it? I think you can. PLA. I know it's done. I know it works, mate, because we've just tried it, but well, I never. Well, I never. There you go, at the bottom. 0 flag and the negative flag. Well, I never. Every day's a school day. Yeah, but in this particular, it's only going to be. It's in this particular instance, it's only going to be 0 or 1. You're never going to be higher than 1, because if you're higher than 1, I mean, what sprite goes so far off the screen? It's in Switzerland. So it's only going to be ever 0 or 1. So just testing the flag is, well, we've just saved 2 bytes. Just saved 2 bytes because we don't need that. Well, I never. Right, so that's the most significant bit. I've tried to explain it as best as I can. I've shown you the direct way, and now I've shown you. Yeah, Quasi looks quicker because I upped his speed, right? Because I added 2, so we could add 3 and make it him faster. Yeah, that's the beauty of doing this method, because now we can introduce sense of speed, as the other way we couldn't have introduced the sense of speed, because we was only increasing by 1 and decreasing by 1. So now he could zip across the screen now, look. So now we're introducing the sense of speed. Yes, we could have a constant setup that is the speed, but you could make this a memory location where instead of actually hard coding it in here, we could set the speed in the memory location, and you could introduce the fatigue effect that when he starts running, after a second he slows down, after another second he slows down even more. Conversely, you can do it the other way. When you have a power up, if he's got a leg it and there's a power up, a speed power up, you could make him run quicker. So this allows you to have that sense of speed now for the sprite. So that is D010 explained, I think. Has anybody got any questions? Do you want me to implement the Y version of this? So we are no longer... So implementing the Y version means we will no longer be setting the sprite directly. Right, let's do that. It should be pretty simple and straightforward, he says with his tongue in his cheek. So we'll do the same thing here. Quasi Y, Esmeralda Y. So here. So LDA 80, so we're all on the same level. We're all on the same level, right. Quasi Y. See, straight away we're saving bytes already because we've just reduced that instruction set down by what? 6 bytes? Yeah, 6 bytes straight away. And so it's all in the jump. So it's all in the jump. So here we go. This is the jump. So it's all about quasi. So here straight away, look, we're going to save 3 bytes there straight away. So we load quasi Y, add the arc, store it. Right, so we do the same thing here. So we copy this. Let's get rid of that now, we don't need it. So this is update Y. So sprite index, accumulator is no longer needed. Y byte. So we don't need to push the accumulator. Transfer Y into A because we need to double it, store it away, times it by 2, transfer it back. We get the Y byte, store it in Y comma Y, load back the sprite number. In fact, we don't need to store it away. No, don't need to store it away because we're setting the Y and that's it. That's that done. That's that done. And then we do exactly the same thing here. So quasi Y, oh, don't need that. Quasi Y, Y, don't need that. Ooh. Now we're doing Esmeralda. Right. That should be it. Yes. So hopefully we ain't broke it. Oh, that's a massive jump. There you go. So we're now no longer talking to the sprite directly. We are updating the XY positions of memory, and then we have a routine that takes that memory and applies it to the sprite. Now it's a bit inefficient at the moment, but like I say, we could write a looper that then looks at all the memory looks at the sprite array effectively, so we would convert it into a sprite array and then apply it to the sprite, and it gives you greater flexibility. Yes, so we're using memory as the middleman. We're using memory as the go-between, but it means that we don't have to worry about working out the most significant bit. We just add it, it becomes a 1, and then that routine then takes that 1 and then applies it to the most significant bit. So we don't have to worry about it. So these two routines that I've just written here, if you do the memory way, so that routine there and that routine there, if you do it the memory way, once you've applied all your updates to the X and Y to memory, all you need to do is just call these update routines for all your sprites, and then that sorts it. And because a typical game loops, you only need to update the sprite at the end of the loop because you've done all your control mechanisms, you've done all your update mechanisms, and then you just want to say, right, make all the sprites appear on the screen where they should be, and then that's it. You don't need to worry about, oh, have I got to set the most significant bit here, or have I got to take it away, or what happens when I cross that page boundary. That thought process just disappears. It's no longer a worry for you. You have a routine that does it for you, and you don't have to worry about it again. So that is D010, and I hope that has, I won't say made it easy for you, but I'm hoping it's taken the fear away of doing it, because I know certain individuals who still remain nameless was avoiding the area like the plague, and said, I'm going to make that as a update routine. Now you don't. Just use the routine, and you will be able to do it. So let's change project. So in this particular scenario, so in this project here, oh hang on, I need to be in that file. So in this project, when it comes up, there we go. As you can see, Quasi is at the bottom. Admittedly, he's walking over fire, but we would now, see, he's disappeared. We would now implement our new routine that would allow him to go from here to here. And that, without us having to worry about, we just copy and paste, make sure the memory location for it, copy and paste it, and that would allow us to get to the ladder, to move up to the ladder and then go back. By the way, did you like the transition? Well, this was Stacy's work. I just I made the fire come to life. I will be updating GitHub with the updated sprite routine. This one, this here, yeah, I don't know what I'm doing with this one yet. I need to put the updated sprite routine into this so Quasi can go all the way down there. You want me to show the transition again? Okay. Right. There we go. It's a bit glitchy. It's not bad for a first attempt. Yeah, it's a bit glitchy. Needs a little bit of work, but it's me trying to, when we move from one hunchback level to another, I wanted to be able to do a Shallan type transition, but maybe not as complex as his. It's not bad for a first attempt. But yeah, we'll be talking about this in a later stream, because what I've done in this, what I've done is this now allows you to load up multiple maps. As before we'd hardwired into the one map. Well, this, so before was this. Before it was this. But then again, is it? Yes, before it was that. So we hardwired that map into the game, yeah, and so everything was, fixed. These are the fixed addresses, and we was updating memory locations here. But in V2 we don't. There is no local memory self-modifying code in there. It is truly now independent. So as you can see, look, I've got two maps that I can just switch between if I wanted to, if I change the routine, and it allows now us to have many maps and be able to switch between those maps, because we need many levels, and if we have many different maps, then I want to be able to load in by just telling it load map number 2, load map number 3, and you can't use self-modifying code for that. It just throws a big fat wobbly. But that is late. That's for another stream. That is on how to convert that first one into a more dynamic one. Hi Faze. So I'm hoping that you've learnt something. I will put this in GitHub. It's been about an hour, I think. An hour and 20. Is it? An hour and 26. Oh, an hour and 26. It's actually got it up there. I don't know what else to do. The whole point of this stream was to understand D010, and I'm hoping that I've done that and taken the stigma away from doing it. Yes, I'm sorry, mate. All right. So hopefully you've learnt something, and you won't be too scared to do it. The code will be on GitHub in about an hour. Yeah, I've been bragging about your Neptune lander, mate. Been bragging about your Neptune lander. Well, thank you a lot, guys, and there won't be a stream next week, and because I'm going to be away, and so the next stream will be in 2 weeks' time, and we'll have to figure out what we're going to do, what we're going to look at next. I might do this charpad thing where we do the conversion to make it dynamic. Alright, so I will see you in the next stream. Take care, guys. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.